Hi, I'm Tom Stone, the National Sales Manager of Industrial Markets for Thermal Care. Thermal Care has been in the process cooling business for over 50 years and serves over 50 different industries.
Today we're going to be talking about the right chiller for you, and really the reason that we want to discuss this and know anything about it is to avoid the cost associated with the pitfalls of selecting the wrong chiller. Could get the chiller that doesn't work right for that type of application, could be too big, too small, things like that. So you could have to buy new equipment, exchange it. So there are some good things to take away here that can really help you to make sure you start down the right path. How many people over the years I've met that have been in the business for many, many years and didn't ever actually know the foundation of this. And so it comes from a British thermal unit, a BTU. And what that is that's a measurement of energy to heat 1 pound of water to cause it a 1 degree Fahrenheit increase in temperature. So to get to this chiller ton, we look at 2,000 pounds of ice, or a ton of ice, and how much energy it takes to melt that completely in 24 hours. What that boils down to is about 12,000 BTUs per hour. And so that's what we call a chiller ton. And the reason that I talk about that is because we're going to start talking about the ratings of chillers, because that's really where you're going to, the major selection point of a unit is does it have the capacity to provide enough cooling for your process? So what I have here shown is a typical spec sheet chart from a Thermal Care spec sheet for our NQ series chillers. In this, we can see the cooling capacity is denoted here in tons. If you see that superscript there, that'll actually lead you down to a footnote. And what it points out is there are some conditions that we are using to rate these chillers. And we call that a nominal chiller rating. It's based upon a 50-degree leaving water temperature and a 95-degree ambient air. Or in the case of a water-cooled unit, it would be 85-degree water. We'll talk more about that, the 95 and 85, and how we're cooling the condenser of the chillers later in this. But to understand what we're talking about here, we just want to make sure that, everything is being measured on a level playing field. So everybody out there that has a chiller that's rating it, when they say a nominal chiller ton, they're using these same parameters. And so that way we're all talking about the same things. I bring up the nominal rating because we can do certain things that affect the capacity of the unit, and you need to be aware of those when you're selecting your chiller. And the first of those, and this is actually one of the most important, it's actually usually the first question I will ask when starting to design a system, is what is the temperature of the water required for the process? And the reason for that is when I change away from that nominal 50-degree set point, I actually will start to change the capacity of the unit. So if we look over here, in the set point demonstrated here, and we have that, a nominal 10-ton chiller that we're using as our example here, as we increase that set point, we actually gain a percentage of capacity with each one. So as we continue up here, we're going to see that we start to raise that, and actually we'll get up to almost an additional whole extra ton of cooling by raising that set point temperature by 5 degrees. In the other direction, if we have to lower that capacity below 50, so we need a colder temperature, we'll actually reduce the nominal rating. So we'll go under that 10 tons. And all of that is dependent on what the process requires. So our units have a range from 20 degrees Fahrenheit up to 80 degrees. So there's a wide variety of different, scenarios that require different temperatures. So we want to be aware of the effect that it has on a chiller's capacity. The other aspect of a nominal rating was that ambient temperature, or the cooling tower, cooling water condenser. And those are actually inversely related. So as that ambient temperature goes up, so as it gets hotter in the air surrounding the chiller, it's actually more difficult for that chiller to reject the energy out. And so therefore it has to work harder and the capacity goes down. One of the things that I like to point out here is that it's both the water and the air, as they go up or down, they affect that capacity. But when you really get into thinking about this, it's the location of where you're going to put the chiller. And we'll talk a little bit more about that shortly. So another aspect to consider that directly affects the performance of the chiller is if you're using glycol. The reason for that is glycol is a substance that's mixed in a certain percentage with your process cooling water. And so normally you could have 100% water, but if your set point is going to be lower and closer to freezing, you're going to want to have a mixture of glycol. Or if your chiller is going to be sitting outside, it's going to be subjected to wintertime temperatures. And so you need glycol to protect from that. As you mix that in there, it becomes a more viscous fluid, so it's thicker. You know, it goes from water to more like molasses, and so it's actually much more difficult to pump that fluid through the system. So your standard pump that you have in the chiller, it may not be able to achieve the desired flow rate of the system, so you need to be considerate of that, and the different percentages of glycol affect it accordingly. So those are things that you need to take into account. Additionally, the glycol being mixed in there actually reduces the ability of that process fluid to absorb energy. It acts almost kind of like an insulator. So it inhibits that energy transfer, which is the whole point of a chiller. And again, that's affected by the percentage of the glycol that's in the water. So those are things to be cognizant of when evaluating your system's requirements for a chiller. I hope that helps you guys, and thank you for your time.